Okay, so let's take a peek here. The first one, negative 42 plus 28. What'd you get? Negative 14. Yes. Network didn't come out, did it? Sorry you guys didn't get a chance to get into it much, but the first one here we had negative 42 plus 28 comes out to be negative 14. From 0 you go negative 42, positive 28, looks something like that. For number 2, negative 27 minus 39. Well, when we have negatives, we like to change subtraction. So this would be a negative 27 plus a negative 39. So from 0, you got negative 27, negative 39. What's that come out to be? Negative 66. It's on the negative side of 0. And since the arrows are going in the same direction, we combine the values. We add the values. Negative 31 minus a negative 54 becomes negative 31 plus a positive 54. Negative 31, positive 54, it becomes positive 23. Our vectors end up on the positive side of 0. They're going opposite directions, so we subtract the values. Then we have negative 8 times negative 3, positive 24. Then we stepped it up just a little bit on number 5. Order of operations problem. I'm going to rewrite the problem down here so I can start just doing some erasing and replacing. Okay, so looking at this, first level of priority is enclosing symbols. I have a couple of different sets of enclosing symbols. So I go left to right and I find this one first. Its other end is down here. So I'm going to be working inside that blue box first. Inside there, however, order of operations still applies. So we're still looking for enclosing symbols. We find another one right there. So now we're moving inside the red box. In there, we look for more enclosing symbols, and there are none. What's next on our level of priority? Exponents. We do have a power here. 3 to the power of 2, which is 9. So I'm just going to erase it and put in a 9. Any more exponents? No. What's next on our list? Multiplication or division. So we do have the 27 divided by 9, which is
3.
3. Perfect. So I'm going to erase that and replace it with 3. Now inside that red box, that inner set of parentheses, all I have left is addition and subtraction. So I'm just going to go left to right. 3 plus 3 is 6. And then 6 minus 1 is 5. So now I've reduced everything inside that set of parentheses to a single number. I can get rid of the parentheses. Do I have to put multiplication anywhere in there when I remove the parentheses? No, there's already an operation here, subtraction, and there's an operation after the parentheses of addition. Only if there's no operation in front or after that we have to worry about possibly putting in a multiplication. Okay, so now in the blue box, we go down through any other enclosing symbols. Nope. Any exponents? Multiplication or division? We have both. We're going to do division first. Left to right. 36 divided by 9 is 4. So I'll take out my 36 divided by 9 and I'll put in a 4. And we still have 4 times 2, which is 8. So I take out the 4 times 2 and I put in an 8. Now we are down to just addition and subtraction there. 8 minus 5 is 3. Next we have 3 plus 8 is 11. Minus 3 is 8, right? So we're down to just 8 inside the parentheses there, which means we can get rid of the parentheses. This time, however, when we get rid of the parentheses, what do we have to remember to do? Put in our multiplication. So now we're done with that enclosing symbol. Back out to the whole problem. Any other enclosing symbols? No. Any other? There are no exponents, so we're going to go to multiplication division. 2 times 8 is 16. We still have 5 times 2, which is 10. And then it's all addition. So 6 plus 16 is 22. 22 plus 10 is 32. Perfect. Now I realize those of you at the far sites didn't have much time to do that because it didn't come up, but anybody have 32 for an answer? Okay. It's a start. You had your first My Math Lab homework assignment assigned Thursday. I know I found out the textbooks did come into Richmond, but nobody knew about it until today. So what I'm going to do is I'm going to give you an extra day to do the homework. If that ends up making it too late to do the quiz, the first quiz is due tomorrow at 11:59 p.m. Let me know and I can extend that. The homework is going to give you a message of it's past due. Just keep working on it. And I'll correct that when I transfer your grades from My Math Lab into Blackboard. What's that? Well, yeah, I'll extend it for everybody. Since it's been an issue. Okay, so any questions? Anybody get into the homework and have a question on it they want me to look at? One of the things I do want to show you with it, these questions not so much will it be affected, but as we get into the chapter here, as you're doing some of these problems, like when we get to the point where you have to enter a fraction or symbols or something like that, we'll end up with, when you click in the box to type in your answer, you see this pops up down here. Like if I need to enter a fraction, I just click on that and fill it in. Or a power, I click on that, and I can put in my, oops, I got to put in my main number first. I keep forgetting that. Like if I need to enter like 7 to the power of something, I put 7, click that, then I put in my power, like 7 to the 3rd power, looks like that. And that's not all of them. If you click on more, it brings up a whole bunch more. If you need to put in an operating symbol, or we shouldn't have to put in pi for anything, but so other symbols you can use to put in there. If you put in a square root symbol, it's right there. You have to play around with it. Sometimes you have to put in a number before you hit it. Sometimes you just hit it and fill in the numbers later. Is there anybody that has not got the textbook or does not, or didn't get the message the textbook's available? Okay, that's good. So at least we're getting closer to having everybody ready to go. Okay. On to the new material for today then. We are going to start today looking at that thing, a variable. What does it mean? Well, a variable has several different uses. A variable, which can be any letter of the alphabet or other symbols. When we get into geometry, sometimes we use Greek letters and other symbols as variables. But anyway, all it represents is a number, but it can represent a number in several different ways. It can be a known number that we have to calculate. It can be an unknown number that we haven't figured out yet. We're waiting to give it a value. Or it can be just a generic number representing a value that could be determined at a later date. So the first use of this we're going to look at is just as a generic number. And the best way to look at that is, let's say that we are told we have a number increased by 7. If I'm going to put that in symbols, how would I write that? Well, I pick a letter. It could be X, Y, N, P, whatever letter I want to use. We'll use X. And how do I show that that number has been increased by 7? Add 7 to it, plus 7. Now, there's a lot of different phrases that could be used to signify this same thing, X plus 7. We could write 7 more than a number. Now, you might be looking at that, well, shouldn't that be 7 plus X? Well, 7 plus X and X plus 7 are the same thing. So it really doesn't matter. 7 more than really implies that 7 has been added to something. The sum of a number and 7 a number plus 7 7 added to a number with 7 added to it, all sorts of phrases that can signify X plus 7. How about this? Three less than a number. Well, not 3 minus X. 3 less a number would be 3 minus X. 3 less than a number implies the 3 has been taken away from the number. So X minus 3. That one's always kind of tricky just because the wording is a little weird there. If it said 3 less a number, that would be 3 minus X. But the than in there makes it X minus 3. Other phrases that might be X minus 3. A number decreased by 3. The difference, just like the sum, the difference of a number and 3. A number reduced by 3. 3 subtracted from a number minus 3. A lot of different phrases that could mean X minus 3. Now I should put a little note in here. Put that pesky little word is in there. How does that change it? Then it would be 3 is less than X or N or whatever letter we use. So slightly different. Let's look at multiplication. I'll go easy on you this time. 5 times the number. How do I write that? 5x, 5n, whatever. We don't need the time symbol in there because it's just implied that it's multiplied. Other ways we could express 5 times the number, or 5x. Well, a number multiplied by 5. We'd have the product of a number and 5 or 5 and a number, either way. A number repeated 5 times. And again, several other phrases that would indicate 5x, or 5 times x. A number split 8 ways. How's that going to be expressed? Division. X divided by 8 or x over 8. Both of those mean division. The fraction notation is a form of division. So other phrases that would mean x divided by 8 or a number divided by 8. Well, a number divided by 8 8 into a number. Now I use sum for addition, difference for subtraction, product for multiplication. Anybody know the word for division? Quotient of a number and 8. And again, there's several possible variations of that. If I look at this phrase here, 4 more than 5 times a number, how's that going to be written out?
4 plus 5x.
Okay, 4 plus 5x would work. 5 times the number is 5x. And 4 more means 4 is being added to something. So it could either be 4 plus that thing, or we could do 5x plus 4. Both of them are going to be the same thing. I have 5 times the number increased by 4. What's that going to look like? Five times, what's that? Exactly the same. You're right. 5x plus 4. How about 5 times the sum of a number and 4? What's that going to look like? Perfect. 5 parentheses x plus 4. Up here, in both of these examples, it was 5 times a number. 5 times a number. So it's just the number, which is x or n or whatever letter we use. It's just the number that's multiplied by 5. And then it's increased by 4. Here, come on. Down here, it was 5 times the sum. The sum is the result of an addition problem, which means we have to do the addition first and multiply the result by 5. That's why the x plus 4 is in parentheses. We have to do that part first and then multiply. So we can translate from English into these algebraic expressions, which I think is one of the most difficult tasks in math. So the only way to get good at it is just to do several of them and start to see the patterns, the phrases and how they fit together and what they mean. So that's going to be a significant part of your homework. Next, I want to look at what are some things we saw up there that we could have x plus 4 or 4 plus x. When we're adding two numbers, it doesn't matter what order we add them in. What operations are we allowed to do that? Is x must, so that's equivalent. Is x plus 4 equivalent to 4, or x minus 4, is that equivalent to 4 minus x? No, it's not. We cannot switch the order with subtraction. What if I have 4 times x or x times 4. Is that equivalent? That's the same. If I put 7 or any number in there for x, 4 times 7 is the same as 7 times 4. Up here, however, 7 minus 4 is not the same as 4 minus 7. One's positive and one's negative. What if I have a division? Is x divided by 2 the same as 2 divided by x? No. Yeah, let's say x is 4. 4 divided by 2 is 2. 2 divided by 4 is 1/2. That is not the same. So we have addition and we have multiplication. This is what we call commutative. You don't need to really memorize that term. It might appear in some of the homework. Commutative just means you can change the order and it does not change the result of your operation.
The term sheet that when you're doing story problems, you know, like of and what they all mean, divide, and your cheat sheet thing?
You know, that's a good question. I started making one of those years ago, and what I found out was like of and will have a certain meaning like 70% of the time, but then the other 20 to 30% of the time they mean something different. And students would get hung up on it. Most often of means this, and they would miss then those where it meant something else. And so I've kind of stopped giving out any sheet like that because students were looking at it and saying, I see this word, so I'm going to do this, and they weren't thinking about what was going on in the problem. And that's kind of one of my big things is formulas where if you see this, then you do this are bad. You've got to look at it and understand what's going on and think it through. And so I found that answer sheet or that key sheet like that made more mistakes, caused more mistakes than it did help, I think. Okay, so addition and multiplication are commutative. We can change their order if we want to. Another big property of numbers that we should look into. What is 0 divided by 4? 0, right? Division means we're going to divide things into pieces. Or subtract. Well, how many times can we subtract 4 from 0? 0. We can't do it, right? But what if we switch that around? 4 divided by 0. Well, how many times can we subtract 0 from 4? A lot of times. We can keep subtracting it forever, can't we? If you punch that in your calculator, 4 divided by 0, what does it tell you?
Error.
It says error. It'll give you some sort of a nasty message. Well, why is that? Well, remember, we defined division last week of, like 8 divided by 2 equals 4 because 4 times 2 equals 8. So if we want to do 4 divided by 0, if 4 divided by 0 equals a number, I'm going to call it x. That means that x times 0 has to equal 4. Is there anything I can multiply by 0 and make it equal 4? No. Anything times 0 is going to be 0. So that's one of our laws of multiplication. It's called the zero product rule. Anything times 0 has to equal 0. So there is nothing I can put in here to multiply by 0 to get 4. So therefore, we cannot divide by 0. Okay. In fact, if we could divide by 0, I could show you some really strange stuff. In a couple weeks after I show you equations, remind me and I'll show you some really weird things that we can produce in math if we're allowed to divide by 0. Okay, anyway, let's look at, now we've got our order of operations and we have variables. We could have something like this. Now we look at that and say, well, what on earth is that? Well, it's exactly what we just did with our order of operations, only we need to know some things. If we let x equal 3, y equal 5, p equal 2, and m equal 11. This is a second use of our variables. The first use was to just translate that English phrase into an algebraic expression or sentence, where the variable is just taking the place of some unknown number. Here, the variables are holding a place waiting for us to assign a value to it. So what I'm going to do, the first step is I'm going to replace each letter, each variable, with its value. So what goes in for x? 3. So it becomes, instead of x plus y, it becomes 3 plus, what's y? 5, perfect. And then times 2 minus 11, good. And now that we've replaced the variables with numbers, it's all order of operations. What has to happen first? Multiplication. 5 times 2 makes 10. And now we're all addition and subtraction. What do we do first? 3 plus 10 is 13. And 13 minus 11 is 2. Any questions? I want you to try this one in your notes quick. See if you can make it work. Now, a little note where it says 2xm, that means 2 times x times m. We just don't write it in there. But try that in your notes and see what you come up with. So on top, p becomes what? 8 plus 2 times 3 times 5, right? On bottom, it becomes 3 times 5 plus 3, right? So what do we have to do first on top? Multiplication. And we start with 2 times 3 is 6. And then we do 6 times 3, or 6 times 5 is 30. 8 plus 30 is 38. How many of you had 38 on top? Good deal. On bottom, what do we do first? Multiply. 3 times 5 is 15. Plus 3 makes 18. So you get 38 over 18. Now that doesn't divide out evenly. So for right now, we would have had to leave that. Unless you want to divide it out and you get 2.11111, or no, 2.22222. Anyway, you guys get the picture there. Let's do one more example and get a little bit more complex. You might have something like this. You're asked to solve for P, or evaluate for P would be one. The big command you would get for this, probably shouldn't say solve, is evaluate. When you get that command, evaluate, that means you're putting values in for the variables. When it says evaluate for P, that means you're going to use the values of other variables to get the value of P. Notice it's P equals out here. So we're going to replace M with the number 4. So it's 3 times 4 squared. minus 7. We're going to place x with 2. So what do we have to do next? Exponents. 4 squared is 16. So we get 3 times 4 minus 7 times 2. What's next? Multiply. 3 times 16 is 48. And then 7 times 2 is 14. 48 minus 14? 34. Good. Any questions? Okay, so now some other things we can look at. We've looked at powers briefly, but I just want to review. If I have something like this, how can I abbreviate that? X to the fifth. Good. 5 x's multiplied together can be abbreviated as x to the fifth. Likewise, if I have x to the third power, that can be split back up into 3 x's multiplied together. If I have x to the fourth times x to the third, x to the fourth is 4 x's multiplied together. X to the third is 3 x's multiplied together. If I'm multiplying all that together, what do I have? X to the seventh. I have 7 x's being multiplied together. Now a shortcut, this is the actual multiplication down here. We are actually multiplying, but the shortcut is, the appearance is, what's happening to the powers? Adding them together. 4 plus 3 equals 7. Now we're not adding, we are multiplying, but again, the appearance is with the powers as they get added together. So x to the 8th times x to the 13th gives us x to the 21. 8 plus 13 is 21. So y to the 5th times y to the 9th becomes y to the 14. Z to the 7th times p to the 4th becomes, perfect, z to the 7th, p to the 4th. They have different bases in their powers. I cannot add the powers. I cannot combine the powers. A little side note, though, when we write our variables with our powers, proper grammar is to put them alphabetically. I don't need the times in there. I just do p to the 4th, z to the 7th. But I should put the variable that comes first alphabetically first in my order. On some problems, my math lab will allow it either way. On other problems, my math lab will mark it wrong. If it does, let me know and I'll give you back your points for that. On the homework, it doesn't matter. Remember, your homework is just graded for effort. But if it does that on a quiz, let me know and I'll go back and give you your points. We are a few minutes early for break, but let's go ahead and take our break anyway. It is 4:17. Let's come back at 4:27.